In a minute, okay?
Okay, the mic is on. So, I want to do these last couple of questions for y'all because I told you I would do them. Okay, now she's back online. Come on. Oh. These divas, I don't know what I'm going to do with them. Let me see if I can pull her up.
I know which one more hungry.
P-A-Y-N-E.
That's a hard pass.
Why? You don't like applesauce? What's what
Okay.
it is?
Okay, so you could.
There we
Oh,
go.
you don't.
Come on.
Because no one wanted it. I was going to eat it.
Having a long tomorrow.
That's my anniversary tomorrow.
Oh, anniversary?
I did. I'm not going to take that off.
What did she say? I'm trying to get, just hold on a second. This thing is totally, there we go. I don't know what the heck is going on.
Anderson. How far away?
What?
How far away is the Anderson campus?
Where are you asking that? Who's asking?
So we can drive to you.
Pendleton?
Pendleton, if you hit Wild Hog Road, which is right beside the Waffle House, if you pass the Waffle House and hit the if you're going toward Anderson and you pass the Waffle House, there's a road to the right, that next red light. If you hit that road, you can be here in 15 minutes.
No, we were going to come see you, but now we're just going to go by Waffle House instead.
That makes me feel good.
Have a party at Hebert, though.
Okay, well.
And next week I'm coming to Anderson.
Well, I tell you what, if you come to Anderson, we'll get pizza. But you got to tell me before you show up now. If Pendleton campus comes, we'll get pizza and have a good old time. All right?
Okay.
Okay.
Next Tuesday.
Pendleton campus is not on the screen. Why aren't they on the screen?
Thursday, we will be there.
We're not on the screen.
Hold on a second, guys. I'm trying to get everybody. What is wrong with this thing?
Go squeeze time.
Let me make it small.
I'll just
There.
I'm going to go back. I'm going to eat some taste open.
I'm going to pasta and pesto.
I have pasta. Did I just call it pasta? I have pasta.
Gotta test.
Okay, there we go. Now, there. Now I've got it to where I can see y'all.
I don't want
Just can't see. I can't see Miss. She don't have her video on anyway, so anybody could be calling for Miss Payne.
I'm
I
not
don't know
going
if she's there or not. Anyway, here's the first question, and it's number 7. I got one like it. I don't know if it's exactly like it. That's this question. Let me get out my questions because I don't know which one I got. All right, the first one. This is cosine, and I'm going to rewrite the cosine as, and what you need to ask yourself, you need to say, okay, I need to rewrite cosine as a sine. I need to write cosine in terms of cotangent. And I need to write cosine in terms of cosecant. Now, with the cosine, that's pretty simple to go to sine, because the Pythagorean, what does a Pythagorean identity say? Sine squared plus cosine squared is equal to what? 1. So the cosine squared is equal to 1 minus sine squared. And that is your, now that one's easy. Okay, everybody should get that one. So we'll graph that one, put that one as square root of 1 minus, but that's not where y'all had the problems. Where y'all had the problems was with these two. So is that the one right there? Yeah, that's it. So how do you go about doing this? Well, it took me probably 20, 30 minutes. Because what did I do? I had to rewrite the cosine in terms of several different identities. until I finally found the right combination. Now, before you say that I'm stupid and I don't know what I'm doing, this is not a problem. One, I've never seen this problem before until y'all sent it to me. Two, you don't write cosine in terms of cotangent, cosecant. So this is like trial and what? Error. Now, I didn't bring the sheet, but I had like 2 or 3 sheets to where I was using different identities. And I finally got it by using the cotangent, cotangent is equal to cosine over what? Cosine over sine. And you solve that for the cosine. So I'm going to multiply both sides by the sine. And that's going to give me cosine theta is equal to the sine of theta times what? The cotangent of theta. Now, is this something you would do all the time? No. So, for those of you that sent this question, don't feel bad about it because it's not really, this one is pretty good, rewriting it. But this right here is not done very often. So now you need to rewrite, and what are you writing it in terms of? The cotangent. So you want to try to keep everything in terms of the cotangent or the tangent or whatever. So if you take the cosine or the cotangent is cotangent over cosecant. How did I get that? By using the identities. And then the sine is 1 over the what? Cosecant. Now what do you need to do? Multiply. So I've got, hold on. Yeah, 1 over the cotangent times 1 over the cosecant. Hold on. No, I got that. I didn't follow my notes right. Hold on. I've got my notes out of order right there. The sine is 1 over the cosecant. There we go. And the cotangent, I just bring that down. So the cosine can be written as now the cotangent over the what? The cotangent over the what?
Cosecant.
Cosecant. Now remember, what am I wanting? I'm wanting everything to be in terms of the what? Cotangent.
Cotangent.
So I've got to change the cosecant to something cotangent. Well, what is the Pythagorean identity for cosecant? The cotangent squared, right? So, yeah. If the cosecant squared, isn't it cosecant squared is equal to cotangent squared plus 1?
Yes.
Somebody look up their Pythagorean identity there.
That's correct.
Yes or no?
Yes.
Okay, now how do I get the cosecant? Take the square root of both sides, and that gives me the cosecant is equal to the square root of cotangent squared plus 1. So I can rewrite the cosecant, cosine theta is equal to cotangent over square root of cotangent squared plus 1. Now how do I get rid of a radical in the denominator? I rationalize the denominator by multiplying by the square root of cotangent squared plus 1 over the square root of cotangent squared plus 1. And that gives me the final answer of cosine theta is equal to the cotangent times the square root cotangent squared plus 1 all over the cotangent squared plus what? 1. And I'm going to tell you, it took me probably 20 or 30 minutes of trial and error to get that. So don't feel pregnant if you got confused on it. Don't feel bad. So which one is it? Should be that first one. All right, now you need to write it in terms of the cosecant. That one took a few minutes too. I think that took a whole page. Well, half a page. Yes or no? Y'all got it?
Yes.
Yes.
No questions. Y'all understand it without no problem?
Yeah.
Y'all are lying through y'all.
Not sure about the
That's all right. You can lie to me. That's fine.
Are there going to be problems like this on the test?
I don't think so. But this is for your homework. So some of y'all y'all want to make 100. So that's why I did this problem. All right. Cosine of theta is equal to the cotan times the sine. And I did that by, let's see, how did I do that? Cosine. How did I come up with that? Oh, by using the reciprocal identities, cosine. Cosine is equal to the cotan. Yeah. Cotan is equal to cosine over sine. And I multiplied both sides by the sine. And cosine is equal to sine cotan. Now, we want everything in terms of what? The cosecant. So that's going to be cotan over 1 times 1 over what? Cosecant. Now, the cotan can be written as the cosecant squared minus 1. The square root of cosecant squared minus 1 over 1 times 1 over cosecant. And then that will give you square root of cosecant squared minus 1 over cosecant. And that should give you the answer. So which one is it? Looks like the second one.
Yeah.
And check answer. So, what did you use? You used 2 things for this problem. One, you used tan is equal to sine over cosine, and cotan is equal to cosine over what? Sine. You also used the Pythagorean identities. That's what you need. And you might have used a reciprocal identity. You might have used those reciprocal identities also. So those are the 3 things that you use in this problem. And I'm going to tell you, to write in terms of the cotangent and the cosecant, that's kind of cumbersome. Capiche?
Capiche.
Here's another one that was sent to me. that I've never seen before. Let's go to it. See if I can find it. Let's see, that's number 7. Let's see who sent that one. Mr. Wilson, does that help?
That helps.
Okay. And that's number 7 too. Miss Valakit, does that help?
I think so, yeah. It's just more knowing where to start and
Yeah, it's tedious. It's very tedious.
Yeah.
Trial and error. So let's go to, let's see if this is the one that was sent to me. Yeah. This one is really not that bad. Okay? This one you have to know your double angles. Okay, so this is the next set of problems. First of all, this first problem, you've got the cosine, 2 cosine theta minus 1. Now that is an identity. That's the double angle identity, and what you do is you multiply this times 2, and you get 45 degrees. So this turns into the cosine of 45 degrees using the double angle identity. Double angle identity. Okay, so since you have 2 cosine squared, you look up the cosine, I didn't write it down, but you'll see it'll say 2 cosine squared theta minus alpha or minus beta or whatever, minus 1, and then it goes into this. That's equal to that. And then, of course, for the cosine of 45 degrees is what? Square root of 2 over 2. This is your double angle of tangent. These are all double angles, I believe. And here, this turns into the tangent of what?
45.
What's 22.5 times 2? 45. So that is 1. So that goes there. The third one, 2, what's 2 times 30? So that's going to be that's going to be the sine of 60 degrees. You have to match 2 sine cosine. What does 2 sine cosine go to? It goes to the sine. And the sine of 60 degrees, square root of 3 over 2. Now, to do 4, this is your angle. So, if you just 4 sine of 3 pi over 8 times the cosine of 3 pi over 8, if you use the identity, that's going to give you, wait a minute, that's for square root of 3, wait a minute, I skipped 1, 4, where's 4? I skipped 4, I'm sorry. Well, I didn't do 4. I did 5 and 6. Oh, well. Well, I'll do 5 and 6 and then whatever's left. I don't know why I didn't do 4. Well, because what's 2 times pi over 6? Pi over 3. So I'll get back to that. But anyway, this right here is going to give you 2 sine of 2 times 3 pi over 8. And what's 3 pi over 8 times 2? It's going to be 3 pi over what? 4. So that's going to be 2 times 3 pi over 4. Right? I'm sorry. Which comes out to be 45 degrees, right? or the sine of 135. 2 times the sine of 135. And the sine of 135 is what? 1 over the square root of 2. And then 2 times the square root of 2 over 2. And then what happens to the 2's? And you get the square root of 2. So that one is the square root of 2. So we've got the square root of 2 taken care of. We've got 1. We've got the square root of 3 over 2. This one, the tangent, got to use the tangent that we used over there on number 2. It's just a different angle. I don't know why I didn't do number 4. Oh, I did do number 4. Yeah. Number 4 is the cosine of 60. Number 4 is the cosine of 60 degrees. And the cosine of 60 degrees is 1/2. So that's that. Pi over 3, isn't that 60 degrees? And how did I get pi over 3? Well, cosine squared minus sine squared is equal to cosine of 2 theta. And what's 2 times pi over 6? Pi over 3. And what's pi over 3? 60 degrees. So that takes care of the 1/2. So I guess by elimination, the last one, I'll go ahead and do it. Tangent 2 5 pi over 12. And that's going to be tangent of what? 5 pi over what?
6.
5 pi over 6, which is 150 degrees, because you always need to find out where you are. 150 degrees. 150 degrees is where? Right there. So the tangent, Oscar had a hump of apple. Of is going to be the square root of 1, right? 1 and negative square root of 3 and 2. So, yeah, negative 1 over square root of 3, which is square root of 3 over 3. Negative, which is that one. So, this problem is nothing but using what? The double angle identities. That one you should be able to do without trial and error. All you have to do is look at the angles that are given and basically just, what is the magic of trig? Finding out where you what? Where you are. And I had one more. This was a verification. This is a test question. I don't know who sent it, but I'll tell you in just a second. That's that one. So does that help, Miss Malaket?
Yeah, I had sent it before I knew what the double angle identities were.
So you were able to work it out afterwards?
Yeah.
Okay.
But thank you for going over it. It's still good to
We
see.
went over this question. I went over that question at least 3 times. And Mr. Wilson, we figured this out after Mr. Wilson, after everybody left. This was different. Your period, or I'm sorry, not your period, but your restrictions were different in the other question. That's why we came out with a different answer. So that takes care of that one. I'm finding this third question. I'm trying to find it. I think that's the same question. Yep. Delete that one. This one is a verification. This is it. Okay, so which side are we going to work with? The right side, because it's more what? Complicated. So we're going to work with the right side. This is a test question also. So cosine theta, cotangent theta, minus sine theta. What is the first rule of identities? Not to find out where you're at. That's the first rule of trig. What's the first rule of identities? Come on, people, don't
Write it
play
all
on
in
the
terms
phone.
of sine and
That
cosine.
just insults my intelligence when you do that. Write everything as far as sine and cosine. So cosine theta over 1
Let's see.
times, what's the cotangent? Cosine over sine.
Fine.
Minus sine theta over 1. All right, so we've got, if you wanted to simplify this, cosine squared over sine minus sine theta over 1. Well, it looks like we're adding, right? Or subtracting. So we got to have a common one. So that's going to be sine here. And got to change this to sine. How many times will 1 go into the sine? Sine times sine is sine squared theta. And that's a minus, and that's cosine squared theta. Now you may think this is headed toward a Pythagorean identity, but it's not. Now here's close to the final answer. Cosine squared theta minus sine squared theta is over sine theta. This is not a Pythagorean identity. It is not a Pythagorean identity is the cosine squared plus the sine squared. So you can't factor out a negative or anything like that. So what other identity has cosine squared minus sine squared?
Double angle.
Double angle. And that gives you cosine 2x over sine of x, which is your left-hand side. And yes, that is a test question. So whoever sent that question, I hope that helps. And the reason y'all sent those questions, I think they're new questions, because one, I haven't seen them before, and two, they don't come with any explanation. If you'll look, they don't come with any explanation, so I don't know what the heck's up with that. Maybe the Russians got to it.
That was a what identity?
The double angle identity. One that has sine of 2a and cosine of 2a, tangent of 2a. All right, so that takes care of, now all the other questions I went over. And I went over them until I'm sick of going over them. So we're going to look at the test now. So you look at the test, you pull up your handouts or your assignments, and the test is going to be half and half. Half bonus questions, half, and you also got 5 attempts. Why do I give you 5 attempts?
Because it's hard.
Because some of y'all suck at it, and you might have to take a couple extra times. And is identities important?
Yes.
Yes. So I'm giving you an extra 2 times because technically there's 20 questions, not 20, there's 28 questions, so you're doing 14. 14 times 5 is what? 60? So even if you didn't do the homework, if you do 5 tests, what have you done the previous 4 tests? You've just done homework. I know, I'm fast. So you're going to do the homework no matter if you do the 5 tests or if you do the homework and the test, you're still going to do homework. It's called repetition and practice. Yeah.
What's that?
That's racist.
What racist people do. Okay, so they're going to ask you now, you should be able to get this. Everybody has a cheat sheet. I pulled it up the other day. Look, I'm going to show you where the cheat sheet is. The green one I told you about. I finally found it. Trig Identity Cheat Sheet. I can't even spell cheat sheet. I suck. It's green. It's down. Oh, hell.
You put try.
Oh, I put what? Oh, man, we better not go with try. That might come up with something funky. Trig cheat sheet. There's one like it, but that's not the one I'm talking about. There it is. That's the one I pick out for my students right there.
Okay.
Let me pull it. There it is. Now, of course, let me see if I can blow it up for you. This is the one I get for people. Yeah, that's the one. Yeah, it is kind of pretty, isn't it? Oh,
It is.
I hate when you mash. There we go. All right, so, and if you see the double angle identities, do you see that cosine of 2 theta? There's the cosine squared minus the sine squared. A lot of people put 1 on that problem, and that's not right. You can't force a square peg in a round hole. You can't force the Pythagorean theorem with a plus into a negative hole. You can't do that. So it's not a Pythagorean identity. It is a double angle identity. And I'm pretty much going to, you've got all of them right here, but you should be able to tell whether one is a function or not. I meant not a function, but an identity. So I'm going to go back to the, where is my, okay, where is my test?
At the
My test
beginning.
disappeared.
If you hover over the Chrome browser on
There
the
it is.
laptop, there you go.
There it is. So the cosine squared minus sine squared, that's equal to what? Double angle. Is that the double angle? Well, you'll have to look and see if another double angle is equal to 1 minus sine. So let me go back to the trig cheat sheet. Trying to do.
Yes, it's an identity.
It is. It should be right there.
Yeesh.
So is it an identity? Yes. So everybody should get that one right. If you get that one wrong, don't what?
Just
Don't
quit.
tell anybody. Next. And you should have 13 or 14 bonus questions. Oops. You can rewrite this. What is the sine and the cosine? I mean, the secant. What is the secant?
1 over cosine.
And what is sine over cosine?
Tangent.
Y'all see how this works? Now, I'm either going to give you the easier ones that you can actually do it, or I'm going to give you a multiple choice one like this. Now, which one is more complicated? Which one is less complicated? Which side?
The cotangent side.
Good job. You always want to go with the cotangent is what you do not think of in terms of, so you would start with the right-hand side. Okay? And that's just rewriting. We did one like that. It's in your notes. Oh my gosh, I don't think y'all can handle this one.
Next.
If you miss this one, you don't what? Tell anybody, because this is a calculator question.
You go cry.
Yep.
I want to read this. How do you...
Bonus. Bonus. Bonus.
Go to the
All right.
phone and go to your fucking notes.
Which one do you think is the most complicated? The
I'm going
left.
to go with
the fraction?
the one the
The
fraction.
left. 1 is a fraction, and 2 is in cosecant and secant. At least the right side, half of it's in cosine. So I would attack the left-hand side. Well, cosecant is equal to what? 1 over the sine, Hubert. And what is the secant equal to? 1 over the
Spent a lot of
cosine.
time on this problem.
So you got 1
I
over
think
1
it's
over, so I would think of maybe a common denominator.
I got all of it right.
And see, or you could just use your cheat sheet and see if you can figure out a way to make this one, its easiest way is to make this look like this.
I could try and do it again.
Yeah, you could actually look at your cheat sheet, or you
25.
could actually prove it.
25.
Okay?
Yeah, I think it was.
Used identities. What is 135? 180 minus 45, isn't it? You could use 180 minus 45. What else could you use? 45 plus 90. Everybody get the point?
What?
You can either do 45 plus 90 and do the cosine, the sum of cosines, or you could do 180 minus what?
No, the one come back here first.
Minus 45. Now, what does it tell you to find? Exact means what? Not the calculator. It means what? Radicals. Exact means, well, I heard somebody do a neigh, a horse neigh, so I just did it back. Okay, so make sure you use radicals here. Did we do one like this? We did about 4 like this. We did 2 with angles. We did 2 with what? Pi. Remember doing 5 pi? You got to find out where you are. We did those. Bonus. 1 minus secant squared. Write the following expression as a single. Okay, that's not very difficult. That's Pythagorean. So you should be able to get that one. Complete the following statement. That is the sum of angles. So one of those, you don't even have to do any math. That's just a cheat sheet. Bonus. Okay, we did this. What is this? No identities. You just have to be able to find the horizontal and the what? I'm sorry. You got to find the phase shift, the amplitude, and the what? If you pick A, don't what? Don't tell anybody, because what's the amplitude? Okay, so everybody should get the amplitude right. You don't have to do anything to mess up the amplitude. So we know at least it's a 33% chance. Given that cosine 2x is equal to 1/3, and we did one like this, remember we did the tangent. Okay, so this is a double angle. So we did one, I think we did one, remember we had to divide it by 2? So we did one like this in your notes. Tapioca. Okay, now I know we did this one because I remember doing this one. Use identities to simplify the expression. Well, what's 1 over the cotangent? That's the tangent, right? And that's squared, so it's 1 plus the tangent squared. So that might be able to help you.
Except I have this one thing I have to do.
Do y'all remember doing these? Are you going to come out with a number, or are you going to come out with just the sign of something?
Just the size.
Just the sign, because you don't have an angle. This is the difference of 2 angles. So you're going to have the sign. What's the sign of 270? -1. So you know the sine of 270 is -1. What's the cosine of 270? 0. So you're going to plug in a 0 and a -1 in places, and you're going to end up with just a trigonometric function or a radical function. Bonus. Okay, there's your phase shift. Which way? To the right, and all you have to do is type this in and find out where it's going. Okay, we know what the cosine looks like. So you should be able to always remember, what is the cosine of 0 degrees? Well, it's 1, 0. So 1, so you know that the cosine starts at what? 1. So it can't be B. So B is out of the question. Use the even odd. Now this is not hard, people. Look at your even odd identities. They're the 6 that's on the right.
So rotating
So
right.
how can you rewrite this one?
So shouldn't 5 be negative?
Negative sine of 4.32.
Both negative, that's what makes it.
Have y'all noticed I've given y'all like 4 or 5 simple problems?
That
You're
one.
welcome.
Thank you.
Tell me why I messed up.
Unless you
Somebody's
answer.
gonna miss them.
I have no idea. I have to
Verify that the equation is an identity. This is another verification. I would go with the right-hand side because it's written in cosecant.
3 pi over 2 over 2.
You don't have to.
All right.
You could start with the tangent and the cotangent, but it looks like to me they're rewriting
Reason.
the right-hand side.
That doesn't matter. That's just so you know what quadrant it is.
Pendleton's talking.
Is
Wow,
it-
what are they talking about?
Talking about math, sounds like.
Oh, y'all just don't talk to me. Okay.
Point.
All right. Complete the sentence so the result is an identity.
Yeah. That's
So what would this one be? We just did this. Sine is equal to tan over what?
Right here is.
Cotan, right? Yeah. Let's see. Cotan, let's write it. Tangent is equal to sine over cosine, right?
Yeah.
That's fine.
And cosine is equal to cotangent over cotangent is equal to cosine over sine. So tangent
It's not
is equal to sine over cosine, and cotangent is equal to cotangent over sine, right?
Because you have to.
Or cosine. All right, now, what's
This is
solve with
located-
sine? Sine is equal to
Yeah, we just.
cosine times the tangent, and you can do it over here. Sine, multiply by the sine on both sides.
Okay.
Sine cotangent is equal to cosine. And over here, cosine tan is equal to sine. What are they asking for? Sine? Sine what? Sine is equal to cosine divided by the cotan, or sine is equal to the cosine times the tangent. So which one is it? A? So, again, I'm not testing you on if you mastering. I just want you to know them, okay? Mastering is when you can do all kinds of things with them. I just want you to be able to find them on the cheat sheet and be able to use them. 27. Okay, we did one like this. We did 2 or 3 like this in class. What's the first thing you do? It's either find out where you're at or Pythagorean theorem. Which one is it? Pythagorean theorem, Hubert. Yes, because what?
Yep.
You're given, Oscar had a hunk, A over hypotenuse, and you know, like you said, find out where you are.
See?
What does it say? It says that, oh, wait a minute. Angle A is between what?
Sorry, take this.
Okay, y'all answering me or talking? Because if you're not answering me and talking, oh, I'm talking, that's rude. All right, where is A?
Between 90, it's in quadrant 2.
Between pi over 2, which is 90, and pi, which is what? So that's in the second quadrant. So A is right there. And I'm not worried about what it is right now. I'm just worried about where we are. Angle B is between what? Pi and pi over 2, so it's in what? So both of them are in quadrant 2. Right quick, all students take calculus. So sine and what? Cosecant, or what? So everything else is negative. So we've got two things. We've got one triangle, and we've got this and this, and we've got Oscar had a hunk, so we know 5 is here, and -3 is here, so therefore you can find O. And then I'm going to draw another, and I'm just doing this to kind of get you started, because some of y'all, you know, even though I tell you to write in your notebooks, y'all write in them, but you don't read them. I don't know why y'all don't do that. Anyway. And there is that, and what are they giving us? Oscar had, so that's 13, oops, and 5. So now you know that adjacent is going to be what? Negative. So 13 is 169 minus 25 is 4, which is 12. Somebody check me on that. And 525 minus 9, so that's going to be 4. And now you have just found where you are, and you have found the Pythagorean. So the rest of it should be pretty simple. Do y'all remember doing one like this?
Yeah.
Now you just got to plug and chug. Find your sign and plug into the sum, the difference, the sum of tangent, the difference of tangent.
Don't do it.
And you feel good about yourself. What I'm showing you is I'm trying to show you that we've covered a lot of this stuff. All right, here's another one. First thing I would do is I would rewrite the left side in terms of what? Sine and cosine. So cosine over 1, 1 over cosine, and cosine over sine, or sine over cosine. You're going to get a lot of stuff canceling out. That's a gimme. Simplify this. I would rewrite it as sine over what? I meant right in terms of what? Sine over cosine. What's cotangent? Cotangent is what? Cosine over sine, 1 over sine, multiplied by the reciprocal, cancel out. What do you get? I don't know. Let's see, cotangent sine over cosine, 1 over sine, sines cancel, you get cosine. Something like that. So, did anybody see anything out of the ordinary?
No.
Everybody should be good. So, darn, I forgot to show the 109. Let me show y'all something right quick. And this is just in case. I know some people brought it up about my 140. I'm just going to show you right quick. And you write it down. I post it on my Facebook because it's a whole lot easier to pull off my Facebook than it is to pull off of what's it called? The TCTC. There it is. There's my 130 right there. I don't know if some of y'all are interested, but there's the 130, which is a good preceding class for the 140. But if you want, there's my 120s and 103. If you want to take 103, that's college transferable also. Just in case you want to, All right, now, new material. And
That's exciting.
How long have I got? 12, 16, I've got what?
19.
I've got like 10, 15 minutes?
Yes,
All
sir.
right. Now these 3 sections are very important. Notice I skipped 2. That means you're not what? You're not responsible for them, Hubert. That's right, class. All right, so 11.1. Why am I jumping to the law of sines and the law of cosines and vectors? Because you are going to be going into physics. If you're taking calculus, it's not long before you start taking physics. All right, so you're going to have to know, just like the identities, you're going to have to know this even more. Okay? The first unit, I taught you how to do right angle trig. Now I'm teaching you how to do right angle trig. As far as on the scale of 1 to 10 it being important, it's a 12. You got to know right angle trig and you got to know non-right angle trig. And that's why I skipped to 11.1. You need to know this stuff, okay? And we're going to just start a little bit. This is when you have a triangle that is not a 90-degree angle, okay? And you can write these down. We're going to go back over this Tuesday or whenever y'all come back. We got faculty wasted day Tuesday. I'm not going. I'm going to be sick. I'm going to try to be sick. I hope I'm sick. Anyway, it's when we sit around the Pendleton campus and do absolutely nothing all day. It's the biggest waste of taxpayers' money.
That sounds like so much fun.
It's awful. I try not to go.
That's what I do every day.
I told them my truck was broke down. So hopefully.
Every day.
Anyway. Oh, thanks. I appreciate that. All right. So we're going to go back over this Thursday, but I wanted to show you where we're heading with it. As soon as I can find one. Okay, here we go. These are the type triangles that you're going to be dealing with. Okay. Now, one good thing about statics, dynamics, physics, is the center of the Earth is usually 90 degrees from the plane, okay? So most of the time, you're going to have a 90-degree angle in there. But with some free body diagrams, you're not going to have 90 degrees because the acceleration force and the gravity is not going to be equal to 90 degrees. So therefore, you have to learn the law of sines and the law of cosines. And the law of sines and law of cosines is basically A over the sine of A equals B over the sine of B equals C over the sine of C. And I don't know, hold on. There it is, right here. So I want you to go ahead and write that down. This one right here. You don't have to write down the other ones. Just this one. In fact, it is easier to use the law of sines and law of cosines than sometimes with right angle trig. Because all you have to know is 3 out of the 4. You have to know 3 out of the 4. What do you mean 4? There's 6 there, Hubert. You don't use but 2 at a time. You see what I'm saying? Do y'all remember is of percent over 100?
Yes.
This is the same concept. You're only going to have 4 unknowns. You're going to have 3 given in each question. So all you have to do is cross multiply and solve for what? X. It's the same thing you did with is of percent over 100. And if you didn't do that, you didn't get your money's worth. So here's an example. Let's see if they give us a drawing. No, they're not. There we go. All right, so I want you to draw this function, okay? And this is where we're going to stop, but I want you to at least put this in your notes so some of you can, if you feel spry, you can maybe look at some of the problems, because some of you may have had this before, some of you haven't. Now, angle side B is always across from angle B. Side B is always across from angle B. Side A is always across from angle A. Is this very important? Yes.
Yes.
And of course, side C is across from. So here, I'm not going to use C. Why am I not going to use C?
Because you don't have either one of the measurements.
I don't have any of the measurements. And that's pretty, and I don't mean to insult your intelligence, but why would you use C if it doesn't give you anything? All right? So here, we're going to use A over sine of A equals B over sine of B. Okay? Now, let's fill in what we have. We have angle A, that's 42.9. Over 32 is equal to x over sine of 81.8. And now we're going to cross multiply and solve for x. Cross multiply, you get x times the sine of 32 is equal to, move this out of the way if I can, is equal to 42.9 times sine of 81.8. And you're going to take that number and divide it by the sine of 32. When you get that, you have found B. Now, I'm not going to ask you to type it in, but when you type it in, it should give it to us on the slide. 80.1 centimeters. 80.1 centimeters. Now, you can find angle C real simple. Somebody tell me how you can find angle C.
You got it. By subtracting the other two from 180.
Exactly. Angle C is equal to 180 minus 32 plus 81.8, and that's equal to some number. Or you can do, yeah, that's pretty much it. I was going to say 90, but you can't do it with 90. You can only do it with 30. So 180, and that's going to give you 113.8, which is going to give you 0.2, I don't know what, 70 degrees, 70.2, somebody check me. What do you get? Well, they'll tell us here in just a second. Let me just hit enter. 66.2, sorry. All right, the whole point is this. If you like puzzles, this is the puzzle section. 11.1 through 11.3, that's all we're going to be doing is puzzles. We're going to be finding and filling in the pieces, and this is very, very, very important for you to understand, especially in your physics, statics, dynamics, thermodynamics. You're going to be doing over and over and over. I done forgot the word for it. Vectors. Vectors, thank you. And some of y'all don't know what vectors are, you will. All right, that's it for today. Y'all have a good weekend, and I'll see y'all sometime Thursday.
Okay.
Y'all have a good weekend.